everyone, this is another video from Easy Electric series, and today we want to design a control system that able to read the temperature data from thermocouples. This is PT100 thermocouple, which able to convert to the current to 0 to 100 to 4 to 20 milliamp. So we have these thermocouple, so we want to design the system like this on the HMI, and we want to read the temperature and also have a nice indicator for a temperature, and also an alarm system. Whenever temperature goes over 40, it should be start to alarming. So let's just give a little hit to this thermocouple and see if this system work or not. So as you see right now, the temperature is around 29 centigrade, and even these graphical indicator shows that's around 29. So now I actually have here a small heat gun. So as you see here, I'm going to somehow give a little hit to this sensor, and as you see, so right now it is 29, so slowly it should be actually goes up. So let's see, it's yes, as you see, it goes to 30 right now, so it should be goes up and up. So as you see, I keep the heat gun much closer, give more heat to our thermocouple, and we start from 29. So now it's 39, 40. Now you see our alarming system start to alarming and telling us the temperature is over 40. So even you could connect the output of the PLC to the buzzer, and also it could be actually make a sound whenever you have the temperature over 40. So let's see how we could program these control systems. So stay tuned. So before we go and take a look to the program, there is actually a little wiring that you need to do, and there is a little theory behind that. Let's explain it. So as you see here, we have the thermocouple PT100. What this thermocouple do? It's actually whenever temperature is 0, it's turned that to the 4 milliamp current, and whenever it is 100 centigrade, it's turned that to the 20 milliamp. So that means any temperature between 0 to 100 technically to convert to the current to 4 milliamp to 20 milliamp. This is what these PT100 do. But in the other side, you have these PLC, these specific models that I have, which is the CPU 1212C AC/DC relay. So if you take a look to the data sheet, which I'm going to show you even in the program, so these PLC in analog input just able to read the voltage, not current. So some PLC is able to read the current, but these specific PLC couldn't actually read the current. It's able just read the voltage in analog input. So we need a trick, because this not convert the temperature to the voltage, it convert the temperature to the current. So this is a trick. You actually put the resistor 500 ohm between the ground of the PLC and the analog 0 that we are going to use, analog input 0. So, and this is a circuit that you should make. So usually these thermocouple has a positive negative. Make sure you choose the right one, so that positive of that is going to the thermocouple. Technically you put this thermocouple in the series with these A0. So positive take 24 to one wire, so the negative of the thermocouple goes to the A0, and also you already have these 500 ohm between A0 and the ground. So what's happened? So this is technically give a current, this PT100, but that current passed through these 500, so then you have a voltage drop here on the A0. So that means somehow with this trick you are able to convert the temperature to the voltage instead of the current. So if we take a look to what we explained, so if we have 100 centigrade, so it gives us 20 milliamps. So that means 500 times 20 milliamps. So that means in 100 you could actually get the 10 volt, which is that's the biggest temperature it's able to measure. So the thing is, already I checked the PLC. So the maximum voltage that these A0 could tolerate is 0 to 10 volt. If you give more than 10 volt, probably you heard this port. So that's what we should be fine. The maximum we want to measure 100 is 220 milliamp. So then 500 times 20 milliamp, it's actually the max that we want. So you actually easily could do the calculation, and now you should understand why we have 500, because we want to the biggest degree, which is 100. It should be give us 10 volt. So the lowest, which is a 0, it give us 4 milliamp. 504 milliamp is 20 volts. So that means the minimum voltage we could get here, depending on the temperature in the 0, is 2 volt. The maximum in 100 is 10 volt, which is right. If you check the data sheet, these A0 could read 0 to 10 volts. So we are fine, and now it should be make sense why we have these 500 ohm here. So you implement exactly the same wiring on the PLC. Okay, you could see the same wiring that I have here. This is my thermocouple. It has two wires. One is positive, one is negative. So this red one is a positive. So as you see, my red connected to the 24 volts. So this is exactly the same thing that I show you in the circuit diagram. So then the other one, which is this green one, comes to the here, which is my A0. This port is my A0. And I put the 500 between the A0 and ground. This is my ground already connected to the M or the ground. And I put the 500 between A0 and also the ground. So what's happened? So technically, my sensor convert the temperature to the current, but these analog input on these PLC that you see couldn't read the current. It's just able to read the voltage. I put the small resistor here that technically able to convert the current to voltage, and my PLC could read the voltage. So what's happened here, this current comes past through these 500. So technically there is a voltage drop between A0 and actually this ground. So technically in other words, we convert the temperature to the voltage with this trick that we have, and our PLC able to read it. So this is what we have in the PLC side. So if you didn't watch my previous video about the sensor and first HMI program, please watch them. I explain everything there, how you could use the HMI and the PLC. So I'm not going to explain them again because it's make this video actually so long. So what I did before, I actually add the PLC to my project, and also I have a HMI which I added. So now you need to program your PLC. This is a PLC side, so you need a norm and scale X. So where you find that operators, so here if you go to the instruction and conversion operator, so here you could see the both of them, the norm X and the scale X. So what's happened here? So you have a voltage coming. It actually is from the analog 0, which is for our case is 0 to, sorry, not 0, 2 to 10 volt. So what's happened? So inside the PLC you have analog to digital converter. It's convert that analog value to the digital value between 0 to 27648. So how I get these number, it is again in the data sheet. You could take a look to the data sheet, and also I show that in my sensor interface video. So technically 0 to 10 volt or 2 to 10 volt that we have for our case coming from the analog input, and it's convert to the digital value 0 to 27648. So how we get this input in the value is our analog input. Easily you could find them. If you go to the device, you click on the PLC, then if you go to the general, here you see AI. So if you open that channel 0, you see the address of the analog input 0 is IW64. So easily you could use that, and the voltage range, it is just 0 to 10, and the measurement type is voltage. That's what I'm saying. These PLC couldn't measure the current. So you could get that number. If you need to do analog analog input 1, so you see the address IW66, but we use the channel 0, which is IW64. So back to the main, yet you see that number IW64 is analog input what we read, so it's convert to the digital value between these two. So then it is normalize them, so that means whatever you have here is normalized and should be between 0 to 1. So you save that inside the double. This is actually a memory double. So then this is scaled. So you read the same thing that you already normalized from the MD0. So then that is going to scale. That 0 to 1 should be scaled between 0 to 100, whichever is our temperature. So then the result inside, save inside the data block. I made it. How you could make a data block, you come to the program blocks, and easily you could say add a new block. So here you choose a data block, okay, and you could make any data block, and you could save a different data, the different type of the data inside that data block. So I did it. So what I made is I make a data block. I call that temperature, and its type is real. It's accessible, visible, and also you could actually write on that. So there is a reason that I put that there. If you put these, you could actually save that inside another double word memory space. But the problem is if you write on the double word, then whenever you use the HMI, writing directly to the memory sometimes do the crazy things on the HMI. That's what I prefer instead of using the double word memory. So I use directly data block, and easily you could tag from the HMI to these data block, and usually it's not a problem. As I say, tagging from the HMI to the double word usually makes some problems, and it's not working well. That's what I did here. Put inside the data block, which is a real number. So now I have just compared that here. I say, okay, if this temperature is greater than 40, it should be actually turn on this Q00 output, which is going to be actually my alarm, or also you could connect that to the light buzzer, and it could be turned on whenever temperature go actually over 40. So if you go to the live mode, you should actually able to see in the live. So let I give the password here, so we see if you could see the live mode too. So see, in the live mode you should actually exactly see the same thing. So here my temperature is 29. So now I'm going to use my heat gun to increase the temperature. So as I already showed in the beginning of this video, you put the heat gun around your temperature sensor, so temperature should be go on, and see in the live mode you should see that increase. So let I connect more. You hold more closer the heater, so it should be take a time. So see, it goes to the 32. So I'm watching this one now is 34, now is 35. So now should be go over 40, and when it is 40 it should be turned this on. You could easily check that in the live mode. So 36, so should be, they actually give more heat. 39, and as you see now, go to over 40, and it's actually able to turn that on. So I turn off the heater, probably it goes actually down, and after it goes down, should be actually turn that off. So this is actually is the PLC part. Let's just turn that off. You say yes. So now let's go do the HMI. So I already explained in the first HMI program in my video, another video. Watch that if this is the first time you are working with HMI. So this is what I did. I put on the HMI side. So I actually use these indicator that you see. I don't know what's the name, indicator or probably your bar. So you put these bar here. So this is actually this one is, which is the IO field is this one, and the alarm is I choose this one. So for setting of them, if you click on that, so you will see on the, I think should be on the general, you see what's the tag of this. Just be careful, come here on the tag. So go to the PLC tags, and the PLC tags, you couldn't see that data block. So probably you should go to the program block, you see that data block, click, and then you choose these tag, which is a temperature. So I already did that, what you see that. So for this one, you just adjust this. That's it, you don't need anything else. So for these for what's the name again, bar, for this bar, here again, you need a tag, the same thing. You go to the program blocks and find the data block you made and choose these temperature real in your data block. So I already did it, so I don't need to do that here. I already did. So that should be only things for this. You could customize that. There is a lot of fancy options here, but we are fine with what we have so far. Yeah, for these alarms, so you need actually, let I go here. Yeah, you go just to the you just add the tag. We already did that in the other videos, so you should just add the tag. So the tag of that should be the PLC tags, right? This is Q00, which we want to turn on. You actually add that here, 01, whenever it is 0 is this color, whenever it is 1 this color. Do you want to flash whenever it is on? You say yes, so it is actually flashing whenever you actually have it. You load it. So then you are going to have this on your HMI. Let's upload this and see, could we actually see the same thing on our HMI. Okay, so after you upload the program, so you will see the same thing here. So for testing that, I'm actually going to have the heat gun. So I connect again, I give these heat gun, I just give a little hit, so it should be start to increase. So as you see, it is increasing, and let's see our alarm will be active or not. So now is, yeah, see now it is 40, so it is active and its alarm is alarming. So I hope you like this video. Thank you for watching.